The third presentation is on a stochastic model for variation of exchange rates in Sri Lanka by Mr. K. N. Alupotha. Mr. Alupotha is currently serving as a lecturer of engineering mathematics, Open University of Sri Lanka. He obtained BSc Mathematics from University of Peradeniya and MSc Financial Mathematics from University of Colombo. Over to you, Mr. Alupotha.
Good evening for all the members. This is going to be a little bit interesting coming from the financial market. This is going to be the stochastic model for the variations in exchange rates. First of all, you know what the exchange rates are. The exchange rate is the rate at which currency of a country is bought and sold against the currency of another country in the foreign exchange market. So it's going to be the interconnection between two currencies. One of the critical factors as domestic inflation mostly occurs on depreciation of currency value. So in Sri Lanka, that is very important. We know that our currency value is decreasing, it's deteriorating because we are not producing anything. That's the main important thing. Okay, we'll deal with those kind of things. Last thing is US dollar has been used as a better yardstick to analyze the exchange rates in Sri Lanka, as US dollar is being concerned as a world most accepted rate denominator. So in our analysis, we are dealing with US dollar, right? Okay, buying price of the US dollar was used as purchasing power of the Sri Lanka rupee is deteriorating. So this is the fundamentals, the basic scenario that I'm looking for. First thing is exchange rates. So it's going to be a stochastic process. Stochastic process means we can't predict what will happen in the future. It is not a deterministic. It's going to be stochastic. We don't know what will happen in the future. A lot of probabilistic terms will come to the picture. And there is a mean reversion as well. There's a mean reversion. So if I take exchange rates, it's a stochastic process, and we can see that it's a stochastic process, we can predict it, and there's a mean reversion as well. Mean reversion means it's fluctuating around one value. It's fluctuating, going up, going down, around one level. So that fixed value is called the mean reversion. So therefore, because of these two conditions, I'm going to use Vasicek model. Normally, Vasicek model is being used for the interest rate modeling. But here, I'm going to use for the exchange rates as well, because of these conditions are satisfied. And this is what you call the Vasicek model in finance. So this is going to be the Vasicek model. It's going to be the first order differential equation, including deterministic term and non-deterministic term. So latter part is going to be the non-deterministic term. You see, the first part is going to be the deterministic term, and the latter part is going to be the noise. That is the non-deterministic or the stochastic part of the differential equation. So here I have defined the terms. Theta is going to be the mean reversion speed. Mu is the mean reversion parameter. Sigma, standard deviation. Normally in finance, instead of standard deviation, we do deal with volatility. Instead of saying standard deviation, we say volatility. Therefore, final one, W, is going to be the probabilistic part. That is the Wiener process. So then we have to determine these Vasicek parameters according to our data set. Then it's done. So this is the methodology. So then this is how I construct the data set. Here I have taken data from 2005 to 2012, daily data, daily authentic data. And I have utilized here buying price of the US dollar, and dollar value was converted to Sri Lankan rupees as well. Then I construct the data set for my whatever the computations. Here I am going to determine the Vasicek parameters. So mathematical computation. So this is going to be very complicated computation, long, but I have summarized it here. First of all, concerning with the Vasicek model, here some substitution is also introduced, and convert into Vasicek model into different format. Actually, this may take a long time if I'm going to take step by step. Therefore, so if you have any doubts, you can ask after the session or whatever. So then what I'm going to do here is I'm going to determine the Vasicek parameters using mathematical computations. Here you can see then you are come across to the normal distribution, because this Wiener process dW, you can see dW. You can see dW. Yes, here I am indicating the dW here, that is coming from the Wiener process. Sorry. That is coming from the Wiener process. That is normally distributed with mean 0 and standard deviation dt. Here computation again coming, and here we have come across to the R. R is normally distributed. First part is going to be the what you call a mean. Second part is coming from the standard deviation. Therefore, mean is going to be the first part. Second part is going to be the standard deviation. Therefore, if you know the mean, if you know the standard deviation, and it says that it is normally distributed, so that definitely we can write the probability density function of the Vasicek model. So then this is going to be the probability density function, that is what we call PDF of the Vasicek model. Right? If you know the Vasicek PDF probability density function, then we can go to the maximum likelihood function, because now we are going to determine the parameters, Vasicek parameters. So then here I have eliminated a lot of computations here, right? Actually, a lot of computations are there, but I have eliminated all the computations, indicating all the important things, or important factors here. If you have any doubts, then I can explain. Now here at the end I have determined all the Vasicek parameters here, alpha, beta and gamma. And here the Vasicek parameters and experimental results. Here this is the result according to the data set. Here also I have the data set. If you want, I can show the data set. Here I have determined the Vasicek parameters. My theta is going to be this one, mu is going to be this one, sigma is going to be that one. Therefore, according to that, I have this stochastic model. Right? You see, mu is going to be 108.3488. That means our exchange rate is fluctuating around that value according to this calculation. Around that, going up, going down, going up, going down, but around that fixed value. That is what we call the mean reversion. So latter part is going to be the stochastic part. First part is going to be the first order differential equation, very simple, but when the stochastic part comes to picture, it is complicated. Right? So this is our final result, and a graphical illustration. Then simulation can be done with the exact value and the simulated value. Here you can see the simulation. You can see the illustration. Here actual exchange rates indicating blue and simulated exchange rate indicating red. You can see there is an error. There is an error. You can see there is an error. It's not perfectly all right. There is an error because we are dealing with risk market. Lot of fluctuations are there, right? Lot of variations are there. Non-deterministic process we are dealing with. Discussion and conclusion. Here I have taken the deterministic process of the final stochastic model. Is going to be this one. This is normally taken from the first part of the final result. I can show it sometimes. You can see taking from this one, solving this one, I can go to the deterministic process. And that means R attains to this value, that is what you call the mean reversion. According to this deterministic part, R attains to this value 108.3488 for long period of time, because you can see that when t goes to infinity, here e to the power exponential decay goes to 0. When t goes to infinity, exponential decay you can see it, exponential decay goes to 0. Therefore, R attains to 108.3488. Final model can be used for forecastings. That is very good. But there is an error. But at least we can get a rough picture about what will happen in the future. Error can be minimized using Monte Carlo simulation. Right? If we run again and again and again, we can minimize the error. Right? But there is an error. So in order to control the depreciation currency value, Sri Lanka government intervention is needed. Improvement of the gross domestic product can be considered as a better economic solution to regulate the depreciation of currency value. That means we have to produce something. These are the references. Any doubts? You can ask. I'll try my best.
Thank you very much. We can take a couple of questions. Yes. Can we have a mic, please? Man, you're sleeping. Yeah, over here.
Thank you very much for your ideas and presentation which you have given. And you showed now nicely this graph where you predicted and what was the reality, what I understood. Maybe we can go back to this graph. A few slides before.
Graphs, you are looking
This
for
one,
the
yeah,
graph?
this one.
Okay.
So the simulated range, this is your simulation result, isn't it?
Yes.
And the blue
red
one is
indicates
then,
my simulation.
this is your simulation. And
Exactly.
the blue one is what you, with the blue,
Blue one is the exact value.
this
sir.
is the exact value.
Yeah.
So the differences are in the order of 10%, sort of, isn't it?
Yes.
You're on the red.
There is an error, right? There is an error.
There's
Right.
a significant error, to my opinion.
Exactly.
And do you also calculate by error propagation the variation of your simulation? That
Actually,
you say,
that's why
it is 110 plus minus, let's say,
Yes.
10 or 20
error
or
is the
50.
most crucial thing, sir. There are a lot of reasons for that because we are dealing with non-deterministic processes.
Yeah.
It is fluctuating. I mean, we can't predict what will happen in the future. It is stochastic. That is what we call stochastic. Right?
This
A
is
lot of
what I understood.
fluctuations are
But
there.
have you calculated this also? And because you didn't show it.
Yes, yes. Actually, here, that's why I have suggested how to minimize the error. We have to run the Monte Carlo simulation. That means we have to run lot of simulation and get the average value of that. That is what you call the final value. Then we have to run lot of simulations, say 1,000 simulations, and we get the average value of the final product. Average value of the final product. Then that is what we call, then error is minimized there.
This is the way how you minimize. This is what I understood.
Yes.
But what is now the accuracy of this red line, you know?
Now here there is an error. But minimize the error, we have to run the Monte Carlo simulation. Now, when this method is introduced, then we can run the Monte Carlo. That means we can run lot of simulations, say 1,000 simulations, and say in 2015 January, we can get the average value of all the values. Average value. Then error is little bit minimized. I'm not saying that error is zero. We can say that error is zero. So any statistical calculation has an error.
Sure.
Any statistical calculation in the world has an error. But we have to minimize the error. That's the main important thing. There's an error, exactly. We can see that. But we have to minimize the error. So Monte Carlo simulation is going to be my suggestion to minimize the error.
Okay. Thank you.
Okay.
Any other question?
In your presentation, you worked out a stochastic point 0.33 like that.
Yeah. Actually,
In your presentation,
exactly.
you made an example and you showed an example. There you showed that stochastic point that 0.33 like that. There was the,
I think you are dealing with the final model, right?
yes.
Let me, this one.
Yeah, that's a
Okay.
stochastic part, yes.
Uh-huh.
Now, what is the effect to that stochastic part to the exchange rate? Is there any cutting point?
That is the noise.
Is there any cutting point to say that this is a good, this is bad, like that?
Actually, it's not good. If there is a non-deterministic part, that means we can't predict. It's not good. But this is the noise. So if I say y equal mx, that is a straight line. But if I add a noise there, then fluctuation is there. That is the noise part. The noise is the stochastic part, which is coming from this dw. That is the noise. Right? If I say y equal mx, it's okay, just a straight line. But if I add a noise there, then it is fluctuating around y equal mx. That noise part is what you call the stochastic.
Okay.
Right.
Any questions?
Further questions?
I like questions. Any questions?
Yes, I have a question.
Okay.
You are estimating your parameters using past data.
Right.
Actually, exchange rates are affected from certain random events like, say, Fukushima accident or
Yes.
9/11 or government change and things like
Yes.
that. But these things do not repeat
Yes,
in future.
actually,
What is the impact of that?
macroeconomically,
Yeah.
yes, I can understand your problem. Macroeconomically, we can say that there are a lot of factors.
Lot of
Macroeconomically, according to the economics, there are a lot of factors. But if I say inflation, macroeconomically, lot of factors. Population, GDP, say interest rates, lot of factors. But if I take practically, sometimes we have to ignore some factors. But that is what you call economics. But when you deal with practical economics, some factors can be neglected. Say for an example, if I take inflation, then monopoly of the market is also going to be a critical factor. But it's not measurable. So that we have to ignore it. That means here I have taken, I don't know whether my answer is clear or not, here I have taken the real data, the historical data for exchange rates. Directly I have taken the historical data.
Okay, thank you very much.
Okay.
Let us thank Mr. Alupotha for the nice presentation.